All right, let's begin. So, hello everyone. My name is Yuvraaj Kelkar. I'll be talking about open source development and test while working on computer infrastructure and how to quickly start getting to start using that infrastructure, right? So, let's say you are an open source enthusiast and you want to contribute to the Postgres source code. Um, Typically what you'd go about doing is start looking for an issue to solve, or maybe heaven forbid you have an issue that you're already facing and hopefully it's not in production. But you look for an issue to solve, you download the source, you do the development to fix the problem that you're trying to solve. You compile, you test, you create a patch, you send it off to the Postgres community for review. um, Hopefully, there'll be no great amount of modifications, but you might have to do a couple of these steps a couple of times, like fixing the issue or making some modifications based upon review requests. You compile, you test, you send the patch, and at the end of it, your patch is approved by the community and it is taken in by the Postgres developers, right? All good. Excellent. Let's see what it takes to actually do all of these steps one by one. So if you've never downloaded the Postgres source, you're going to start off by Googling for the Postgres source. And Google, surprisingly enough, gives that first link as the GitHub repository instead of the Postgres repository, which is fine. Even so, it does say that it is a mirror of the original Postgres. At least the second link is the top source of the Postgres repository, which is good. We'll go to clone the GitHub repository. It's perfectly fine, no big deal. What we are supposed to do next is figure out how to compile the source code. So the first thing is to read the fine manuals. You look at the README file, you look at what is expected to be done to start development. Here is where you'd get some important links such as, or what you'd expect to get is what you're supposed to do to install the dependencies to build and test Postgres. Um, Sometimes it's in a README file, sometimes it's in an install file. In either case, you're supposed to go through the documentation and figure out what to do. So if you look at the README file inside Postgres, you see that there isn't much information other than to just go to those specific links. There is no install file either. So what I did next was to actually go to the download link and look for the sources that I could download from there. I picked up the 13.2 version because it's the latest one that was available at that time, extracted it, and finally found the install file. Now, there is a reason why this install file isn't present in the Git repository, but it is available in the tarball of the sources, but that's a conversation for later. You'll probably get it once you do the compilation. In any case, let's look at the install file. This is where the next level of reading the fine manual begins, where you're supposed to understand what tools you need on your development machine for you to be able to compile and test Postgres before you actually send out your patch to the community, right? You'll read through this and you'll see that you need things like make, you need the gzip libraries as well as tools, you need tar, you need a bunch of other things. And this install file is written in such a manner that it is possible for anybody with the appropriate amount of skill to figure out what commands you're supposed to run for your particular distribution. It doesn't give the exact commands. It doesn't say that if you're using Ubuntu, you need to say sudo apt-get install libz or gzip or tar. It tells you what you're supposed to do, and you're supposed to go figure it out on your own. Okay. Now, we are experienced people, and therefore we know kind of what we're supposed to do when these packages are to be installed. But it might be that a new person doesn't know what commands are to be installed or are to be run to install the right packages. Furthermore, it might also be that I'm using Ubuntu, but I want to try this out or compile and test Postgres for, say, CentOS or Fedora or something else. And what we decided was, let's make this thing simpler, not just for ourselves, but for everyone else. And so the expectation that we realistically had was, even before I got to work on Postgres, I will have to do a whole bunch of installation steps. So how long does it take? Now, even for somebody like me who has done this enough times in the past, it took me between half an hour to an hour to get a clean working setup. But then I also realized that I had to take that much time because there were a whole bunch of competing libraries that I had to juggle with, or I might have to juggle with, not maybe not right now, but in the future when I install other things on my machine. Then comes the question of, is my machine uh, strong enough, heavy enough, capable enough? Does it require more memory, more cores? Am I going to be able to do anything with my laptop which does not have additional memory? Or how do I go about doing this? Maybe I need to use a cloud provider. So how do I create instances in an AWS, in a Google Cloud, or all of those things which turn out to be, am I really an infrastructure engineer, or do I just want to get to work on Postgres, right? There has to be an easier way for this. And so one of the easy ways that used to exist in the past was using ch roots. So you create a ch root, you install all of your things inside it, and well, you've got a working setup that you can then go back into when you need to work on a particular set of uh, environments, right? Since 2013, Docker has turned out to be the CH root for us. And so what we did was we created a Docker file that would encapsulate all of the dependencies required for a bunch of platforms. We did this for Postgres, we did this for others, and we just made it open source because if it needs to be easy for me, we can also make it easy for everyone else, not just us. Okay. All of these open source links, by the way, are available at the end of the presentation, or you can just ask me for it. It's fairly straightforward. You look for Docker images and you'll see a whole bunch of these Docker images that we have created, not just for Postgres, but for a whole lot of other projects, or open source projects as well. So this is what the easier way turns out to be. It's one single Docker command, which uh, picks up the Docker image that we have created and runs the commands that need to be run for building, testing, the entire Postgres source code, right? It does look a little arcane, but at least I didn't have to install anything on my own to get to writing code for Postgres and compiling it directly. I don't have to think about, do I have the right dependencies? Everything is set up for me. This is great. So now I can get to my contributions, right? Let's say I have to do this for not just myself, but for the community. Or think about it in terms of, I've done it for my machine. If I have to do it for another machine, what do I have to do? I have to clone the source and I have to just use the Docker image to build and test. Great. It has become easier in that sense. But is the new machine good enough? Does it have enough memory to do the builds and tests? Does it have enough disk space? Are there enough CPUs to stress the system? How much time and money do I have to actually set up all of these things? Okay. Is it that hard? So what we did was, there was a survey that was sent out some time ago asking for people, asking for whether people had contributed to Postgres. And unfortunately, the answer was kind of disappointing. 85% of people have never contributed. Now, there are a lot of reasons for this. I'm fairly sure of that. But we can at least address the reasons that we understand and can help with. So we started off by trying to make it easy for developers and the community in general to start contributing to Postgres by making it possible to use simple commands just to build and test it, and pre-configured machines so that the community can just get to their contributions, right? Effectively, what we're trying to do is, you come in with your laptop, your desktop, your cloud instance, whatever you want, you clone the sources, and you run a single command to build and test. It should be that simple. Okay. So you get the code, clone it in whatever URL that you want, and build and test using a single command called Crave run. Okay. What Crave run actually is going to do is going to spin up a machine, start off a Docker container. It is going to get your code in there, start the compilation, do the test, do everything, and return back to you the entire results in real time. Okay. Let's see it in action. Okay. So on my machine out here, I have a Postgres clone that I have done out here. It's from the GitHub repository. Even though it's a mirror, it is a valid mirror of Postgres. What I'm going to do to actually start compiling is exactly what I said. So as I say, crave run minus minus clean. And what Crave is going to do is it's going to run this compilation, which includes a bunch of predefined commands that are required for building and testing Postgres source, which is going to be make world and make check world. In addition to any of the configuration steps that are expected, it will do all of this inside a Docker container, which will be run on contributed infrastructure that has been contributed to Postgres and other open source communities. It is going to do all of this seamlessly. If you notice, that's the only command that I actually had to do to make it all happen. And it will stream back the results back to my machine in real time. The contributed infrastructure in this case, if I remember correctly, is 16 core machines and with an enormous amount of memory. So your check world testing, integration testing commands are not going to actually come in the way of doing other work that you might be doing on your laptop or your desktop. It's all going to be shuffled off to a remote location. You're getting all of the output happening real time. There is all of these things are not running really on my own machine. It's running on a different machine. This is evidenced by the fact that I'm doing this on a Mac. I would be hard pressed to figure out exactly how to do development on Postgres using my Mac and not have to fiddle around with Brew or other package managers like that. Okay. This is great. This is the demo. At the end of the compilation, it also is going to do the build and it's also going to do the check world, which will take another few minutes. We'll let it happen in the background. Um, that we all, since we've done this for Postgres, we've also made this available, this exact same set of features available for MySQL, for MariaDB as database representatives. We have also done this for Foundation and RockDB. We have also made it applicable or usable to other open source projects like Rustlang and Golang, Kubernetes, even the Linux kernel itself, and other CNCF projects like Envoy. And we've got a growing list of open source projects that we have made this contributed infrastructure available to. So the basic idea out here is go forth, contribute. Um, let's go to, if you have any questions or comments that I can't address out here during the presentation, you can contact us at crave.io. But I'm ready for any questions that you may have. Oh, just looking at a question. Okay. So a regular build as on Crave, removing all of the setup complexities. So if you ignore all of the setup time, which is between 30 to 60 minutes, as I said, normal compilation for Postgres takes about 10 minutes. The build and the testing part of it is a little bit more after that, but the entire thing within Crave completes in about 3.5 to 4 minutes, if I'm not mistaken. So in the next 3 or 4 minutes, it will complete. You see all of the tests are also being completed out here. So the answer to that question is about 4 minutes. The setup complexities themselves are a significant amount of effort, which cannot easily be quantified in the amount of time that is spent on it. Because I have worked with enough open source projects, it takes me a far lesser time than most people. Other people may take more time simply because I have read enough number of install files to know when the file says you need gzip, what exact commands I need to run for Ubuntu or CentOS or Fedora or whatever. Um, it varies from person to person how much time is going to take to set up your system. I would okay. So the question is it better to propose a change before creating or submitting a patch, or at the same time? I'd say the sooner you say, propose a change, the better it is. You'll read this in the Postgres wiki as well. The sooner you get other people involved in your contributions, the better it is for you and the community itself. You start off at the design phase of your issue, and you constantly keep in contact with everyone from that point itself. Don't wait until you have finished compiling and testing to give your patch to somebody else to look at. Always start off from the beginning. Always start off. I mean, in fact, I'd go so far as to say that unless it is so well known an issue that there is already a bug filed for it and somebody has told you to work on it, let the community know that you're going to start working on it. They will guide you through what would be the most appropriate way, because in general the knowledge contained in the community is going to be the knowledge of the entire design and the history and the reasons why things they are. So if you were to come up with a fix on your own, you may or may not have all of that ammunition in your mind. But if you ask the community, they'll actually be able to guide you. It's definitely worth talking to them before you even start. And this is not just Postgres, by the way. This is anything, any open source project. You don't have to restrict this to Postgres. Oh yes, Crave can actually. Also, the question is, can Crave be used to create your own private builds if you cannot immediately contribute? Yes. So even in the demo example that I gave, there I had all of the sources on my own machine. While I was making those modifications, I did not have to actually push those changes. Um, in many cases, there is nothing to push to. You may not have permissions to push to the remote repository. Git is a distributed version control system, so you're expected to be able to work with patches alone. So you can have completely private patches. That's one part of the answer. You can even have completely private repositories, and that's a totally different part of the Crave solution. That I mean, it's not. So once you make private repositories, they may not even be open source, and that is a totally different conversation. We'll have to contact us. Um, we have made this contributed infrastructure available for open source for free, because there are no constraints to non-open source code when we are doing that. For non-open source code, please contact us. For private builds, on the other hand, on your own, I mean, let's say you are going to work on a Postgres feature that is that you don't want to disclose for whatever reason until you're ready with it. Now, I'm not saying that this means that you're going to add features that the community is not willing to accept. I'm saying this from the perspective of a developer who is quite often embarrassed to give out contributions before I have actually cleaned them up. Um, I have bad coding habits. My documentation is not up to snuff while I'm writing code. If you're talking about private builds in that sense, yes, Crave completely supports that. Do as much as of your own private work in that sense. Uh, there's no restricting that at all. All right. We are a little bit in advance of our time. If there are no more questions, or if there are other questions, you can always contact us at contact@crave.io. There's also the Crave.io website where you can leave us messages directly. Oh, uh, so on the Crave website, you'll see a list of projects that we support. Let me just open it up and show it to you. So there is no sign up required. You can just start using it for the list of projects that we already do support. For example, Postgres, as I showed you, but we have a whole bunch of these others. All you really need to do is just run Crave. It will automatically work. There is no sign up involved. If you do have questions, you can contact us at our email address. If you have messages, or if you have certain projects that you'd like us to support on your behalf, please leave us a message. You can always leave us a message out here or send me an email at contact@crave.io. We keep on adding newer and newer open source projects out here. The eventual goal is to be able to support any open source projects that wants it. Um, and this is all through infrastructure that is contributed by our partners. Um, we have Nutanix and Equinix in the mix already. There will be more as time goes by. Okay, the question is, how do I use this for work projects in a company? So if your company is working on open source, um, you just use Crave Run. It will automatically use the contributed infrastructure. If you plan to use this for your own source code internal to the company, Crave can be deployed into your organization. Um, it is a fairly straightforward deployment. Then the developers, instead of referring to the open source contributed infrastructure, can refer to your own internal infrastructure or your cloud instances that you want to use for it. With that, then you can work on not just open source, but even your internal source code, which may or may not be open source. That's up to you. The Crave can be deployed on all of the known public clouds: AWS, Google Cloud, Azure. It also works on premise in Nutanix, on Nutanix infrastructure, as well as VMware infrastructure. All right. If there's no more questions, I can give you guys back your time, about 7 minutes more.